welcome to the deep dive. So today, let's tackle something you might hear floating around, this idea of rain-powered solar panels.
Right. Sounds a bit futuristic, doesn't it?
Exactly. It's not literally that, of course. But what is fascinating is the connection, the synergy between solar power and water, especially somewhere like New Mexico.
Absolutely. And that's what we're diving into today. How solar infrastructure there isn't just about watts and volts. It ties into water cycles, uses rain smartly, and connects to bigger sustainability goals.
Okay, so let's start there. Rain in the desert,
Yeah.
helping solar panels. How does that actually work? It seems a bit backwards.
Well, it's all about the dust. Dust is a huge problem for panels in dry places like New Mexico. It can seriously slash efficiency, sometimes, believe it or not, by up to 50%.
50%, wow.
Yeah. So even though rain isn't frequent, when it does come, it acts like a free cleaning service. There was a study in 2024 looking at places like Alamogordo and Roswell,
Oh.
and it showed that after a storm, the PV output, the actual electricity generated, jumped by 15 to 20%.
15 to 20. Just from a rain shower.
Just from the rain washing off that dust.
Yeah.
It means less need for, manual or robotic cleaning, which costs money and resources.
That's a huge bonus, that natural cleaning. But what about taking it a step further, like actually designing systems to capture that rain?
Now you're getting into some really innovative stuff. People are definitely working on that.
Like hybrid systems.
Exactly. You've got companies, Green Rain Solar Inc. is one example. They're putting rooftop solar together with gutter systems to collect water for irrigating nearby plants or green spaces.
Interesting. Combining the two functions.
And it goes beyond just watering plants. Think about water purification. MIT's been testing a solar desalination prototype right there in New Mexico.
Desalination, using solar power.
Yeah, it uses almost all the solar energy it captures, about 94%, to purify brackish groundwater. That's water that's too salty for drinking or most farming.
Okay, I see. So it makes unusable water useful.
Precisely. Their pilot plant down in Socorro, just this year, is producing 5,000 liters of fresh, drinkable water every day. That's massive in a water-scarce state like New Mexico, especially since so much of their groundwater is brackish.
That's incredible potential. And I've also heard about solar panels changing the environment under them. Agrivoltaics, is that the term?
That's the one, agrivoltaics. It's this idea of putting elevated solar panels over crops.
Okay.
And it creates this sort of symbiotic microclimate. The panels shade the ground, which keeps it cooler, sometimes up to 10 degrees Celsius cooler.
10 degrees, that's a lot.
It is. And because the soil is cooler and shaded, it holds onto moisture much better. For crops like chiltepin peppers, which need a fair bit of water, studies showed they needed 47% less irrigation under the panels.
Almost half the water saved, just from the shade.
Exactly. And it helps the panels too. Solar panels actually work less efficiently when they get too hot. They lose about 0.5% efficiency for every degree over 25 Celsius.
So the cooler conditions underneath help the panels perform better.
It's a win-win. Cooler panels, less water needed for the crops. And studies like the Big Semi Solar Project confirm this boost in soil moisture without, changing the overall regional rainfall patterns.
So it's not just about power, it's about managing the whole local environment. That holistic view seems to be reflected in policy too, like New Mexico's Solar for All program.
Yeah, that's a really important initiative. It's got $156 million in EPA funding from 2024, and it's specifically targeting low-income and tribal communities.
Why that specific focus?
Well, historically, these communities have often faced, higher energy costs and more challenges with reliable access to resources like clean water.
Right.
So this program pairs shared solar setups with things like rainwater harvesting tanks. They're doing this in the Navajo Nation, for example, where water access can be a real struggle.
So it's energy and water security together.
Absolutely. The projections are huge, saving over 116,000 tons of KERO and nearly $300 million in energy costs over 20 years, plus the water benefits. And innovation keeps going. Green Rain Solar is even looking at using rainwater to help cool batteries at solar EV charging stations.
It really highlights the economic and environmental angles. We often hear about water use and energy, but this flips the script.
It really does. Utility scale solar uses, I think the figure is 1/1500th the water per kilowatt hour compared to coal plants. That's a massive difference in an arid state. Clean energy becomes a water-saving strategy.
And the economics seem to back it up.
They do. Those green rain solar projects combining solar and water, they're seeing a return on investment in about 12 years, which is actually faster than some standalone solar systems.
That's to ROI. Interesting.
Yeah, and the Solar for All program, looking out 20 years, expects benefits, energy savings, water, health, to outweigh the costs by more than 3 to 1. Plus, you can use land that might not be suitable for much else, like contaminated sites. The Samis project uses 1,600 acres of such land.
So pulling this all together, it's clear New Mexico's solar story isn't just about making electricity anymore. It's really becoming central to how they manage resources overall, especially water.
That's the key takeaway. It's this integrated, water-smart approach. New Mexico is kind of becoming a blueprint for how to do sustainable development when water is scarce.
It really makes you think. So the question for you, the listener, is this. What does this integrated approach in New Mexico teach us about managing our resources? And how can these, maybe surprising connections reshape how we think about sustainability as we face challenges like climate change and water scarcity?
Yeah, how interconnected are these systems, really? Something to chew on.